Okay, guys, thank you. Everyone is okay after the second round of burritos. It can be challenging to be in high attention after that, but I hope that what we will talk about today will be interesting enough to keep you guys engaged. So we're not going to talk about Kubernetes. We're not going to do that today. We are going to talk about microservices. We're going to talk about architectures, about multi-tenant architectures, and about the son that nobody wants, which is the database part of the story. So typically the database is the area that got pretty much untreated or treated badly. We throw more money on databases, and then all of a sudden RDS or Dynamo become like the second line item in our AWS bill, and nobody knows how the hell did we get there. So these are some of the things that we're going to talk about today. My name is Matan. I'm the co-founder, CEO, and CTO of Rapido. We started the company about 3 years ago. We raised $8 million from VCs across the globe, mostly in Europe and Israel. And I'm based in New York. So if you are around, and there is a big chance that you are, we have a WeWork office on the 9th Avenue. So feel free to connect me on LinkedIn and come by to say hello. Let's dive further into what we do. There is some text. I know it's quite heavy, but we are going to do a live demo in a few minutes. Hang tight there. So what really is going on? So we saw that many SaaS organizations with a large amount of microservices, B2B companies with tenants sitting on their applications are enjoying quite a lot the benefits of the cloud. We auto scale. We use Kubernetes. I did say Kubernetes. We use Kubernetes. We do auto scale. Then we love to use managed services because that offloads like a lot of heavy lifting. Who wants to manage like a MySQL database on their EC2 instances today? Nobody wants to do that. That's not fun. That just generate a lot of issues and problems. And who knows how to do it, right? That's like an old breed, like those DBAs, right? So we use managed services. We use cloud native applications. And one of the problems that all of us with microservices and multi-tenants have is that the underlying databases layer is something that we have to manage separately. So we have a different service for each application. We see that our tenants not interfering with each other. We make sure that one service doesn't interfere with another service, but then when they all get into the same database, nothing that we did matter, right? So this is why most of the companies that we see out there decide to split their underlying database layer based on all kinds of business logics, but mostly it's either DB instance per microservice or DB instance per tenant, right? So we want to protect our tenants. We want to protect our services from noisy neighbors and to make sure that the SLA that we committed is actually up and running. And since we use those managed services, we don't see a lot of DBAs there, right? Like we see that child that nobody wants to adapt, like the database. So developers we shift left. We give developers more responsibilities on the database. They create the queries. They use ORM. Nobody sit and write SQL today, right? So they use ORM. Then on the other side of the scale, we have the ops team, the SRE team, the platform team, that in the end of the day, as my friend Walt says, it's not their fault, but they are responsible. So we see that it is very hard to manage that underlying layer. And there are a lot of problems coupled with that. Like, how do I make sure, think about it, like in a microservice, when my CPU CPU spikes, I automatically auto scale, right? All kind of pods and nodes are born and helping me to scale my application, right? But when I have database, in the end of the day, it's a shared everything architecture. If my CPU spikes and it gets a bit over the roof, my database is down, my service is down, my entire application is down. So how do I make sure when I manage 500 databases that none of my CPU spikes is getting close to the edge? How do I make sure that happens? It's very hard. It's a very hard problem to solve. How do I gain visibility to basic stuff? What is the slowest query across my entire fleet? I have 500 database. What should I really take care of today? How do I become proactive and not reactive? How do I make sure that I take care of issues before they hit my clients? So all kinds of problems are coupled with managing a large fleet of databases. How do I make sure that I scale down the latest database that I scaled up because of the spike that I had? And Dev told me, why can't you just scale this instant up? Just throw a bit more money on that because we have bigger problem to solve. How do I make sure that I scale it back down? Do I even want to scale it back down? When will be the next spike? So these are all kind of hard problems that SRE, DevOps, platform engineering teams are having. And we see that vicious cycle, right? Like these guys, they are building software. They sit, they write in Hibernate, they write in Python, they write in Java. There is like an ORM layer, generates query. We see those nasty queries in RDS Performance Insights or in the tool that we have to monitor our databases. And we don't live in the same world that they live. We live in minutes. If I have a CPU spike that I need to address, I need to do it right now. I can't wait for another cycle. So what do? I just throw money on that. I increase my DB instance. If I have an SLA issue, I throw money on that. If I have a performance issue, I throw money on that, right? So in the end of the day, I can't really make my KPIs on the database area if I am an SRE, if I'm a DevOps, right? And this is exactly the problem that we solve at Rapido. Gonna move to a live demo now. I had some slides that I thought about putting in, but I don't know. What do you think about that slide? You like it? Makes sense? I don't know about that. It's hidden. Anyway, so guys, here you can see the Rapido console. So what you see here is essentially, and we move to a live demo. Maybe I can, Miko, you can take this. Yeah, you know what? Let's keep it. So here you can actually, I think that my hyperactivity will make me walk again. I'll keep this guy with me. So guys, what you see here. So essentially Rapido, think about it like as another application, another software that is connecting to your databases, right? It opens a connection to MySQL and Postgres databases. We don't sit in line. We can sit in line, but initially we don't sit in line. And we start aggregating data from various sources. We collect data from the process list, like we lift the hood and we see what's happening under your databases. So that's it. RDS is no longer a black box that I don't know what is happening there, right? All of a sudden it's a transparent box. I can see exactly what is happening there. And I can also show you how can I take actions, right? When I connect to 500 databases, I want to see from the bird eye view if there is something urgent, if there is something that might require my attention. So I get visibility to the average query time, to the longest query. I have a 5-minute query on that database. I drill down. I can actually see every line item that you see here is a query on a database or a schema on an instance, right? So you can actually see the most pressing issues across my entire fleet. So I can sort by minimum duration or by maximum duration or by average duration. And I can see that there is a query that was running in the last, so my context now is 12 hours, right? So in the last 12 hours, it ran, let's see, it ran 12 times or 28 times, and it's very slow. Okay, I'm aware of that. We can also see that it happened on a database called demo on a DB instance called DemoDB. Okay, that gives me information. I can easily see here that this DemoDB is sitting on 99% CPU. So I can actually understand that there is an alarm, right? We have a red alert here. So I want to go and see what is happening on that database now. I want to go to real time. So I move to the instances view. In the instances view, guys, you can actually, this is like science fiction for, I guess, for a lot of you, right? Like I can actually sit here and see Postgres, my SQL instances sitting all under the same pane of glass in the same grid. And I can actually sort by any column that I see, I can group by. I can group by my AWS accounts, right? So if I have multiple accounts, I can manage all the databases across all my accounts, across all my regions with Rapido, right? So I can group by account. I can group by database engine, right? So you can see that I have 12 MySQL databases, one Postgres database. And now when I sort by CPU and expand the MySQL again, you can easily see that one of my databases, sure enough, DemoDB, is stressed to 100% CPU. Oh my God. It is so stressed that it is down. No, It is up. Okay. So you can actually see that database is really generating a lot of traffic. There is something going on here. We have slow queries. We have a query that runs for more than 5 minutes on that database. It is all real time. I constantly collapsing that. We can get rid of the group by, right? Like we don't really need it for that demo right now. So when I sort it, I can see that I have high CPU utilization, 100%. I can see my instance type. I can see my database engine. And now, as the spoiler showed you, I can actually drill down and see what is happening within that database in real time in 3 seconds interval, right? So you can actually see all the queries that are running here. You can see that there is something very irritating happening on that database. This query is running multiple times in parallel. I can go and I can group by, and I can see that this query is running on that box 230 times in parallel right now. Now, since we are giving you the real-time context, I can also give you actions that you can implement, that you can do in order to solve the issue. So it's not only that I can show you what is happening here, I can actually give you a trigger to pull to start fixing the issue, right? So I killed that batch. You will be surprised how hard it is, like to kill 200 queries that are running on your database right now. So it is happening behind the scenes, but essentially nothing really happens, right? Because my application is constantly throwing that query back on my database. So I didn't really solve the problem. And come on, between us, do you really want to kill queries in production? Sometimes only if it's a query for mass distraction, right? Yeah, only mass distraction queries. But like typically, that's a trigger that you think twice before you pull. So what you want to do now is to be proactive. I want to do something surgical about that. So as you can see, we have a select SQL calc found rows, and it's running 150 times, but it's spiking back up again. So I'm going to select that text, right? And I'm going to go to the world of automation. So guys, this is where Rapido differs on any other solution on earth, right? So everyone out there, let's start with the cloud native tools, RDS Performance Insights, will give you a very narrow view to one DB instance in parallel, right? If I look on one DB instance in parallel and I have 500 instances, by definition, I cannot be proactive. I have to be reactive because I can't go and look on 500 instances in parallel. The other monitoring tools in the world, you know all about them. They give similar approach to Rapido. They don't do it in real time. They don't do the aggregated view and everything, but they give you the visibility across instances. They don't do automation. We're the only tool in the world that essentially shifting right. So everyone is shifting left, right? We want to give developers more responsibilities, more power, but then it's not my fault, but I'm responsible, right? So I'm responsible for what these guys do as an SRE, as a DevOps, as a platform engineer. So what we want to do is to shift some of the responsibilities right to the SRE team, okay? Some of the capabilities, give the SRE some tools that they could actually control what is happening. So look at what we see here. So this is our wizard now. Now I will leave that mic, and people are told here. Okay, so we have, look at this. We have a triggers and actions engine, right? This is a platform essentially that can do anything you want to protect your databases. So let's be brutal, right? So I want to say whenever like someone is executing, this is my SQL editor, whenever someone is executing that exact query, and you know what? Not that exact query, but anything that falls in that pattern, I don't care if it does it from the parents table. I don't care if it does limit 5. Just going to block them, right? Maybe that is too brutal, right? So at least let's block them in certain times of the day. At least let's make sure that they don't do it on business hours, right? Because I have some critical traffic hitting my database, and let's do it on Monday to Friday, right? So do your idiotic queries on weekends. Don't do it on my business hours. Don't wake me up. Don't take my attention. The lady from PagerDuty talked about alarms, false alarms, right? So this is one way to stop alarms, right? Don't throw shit on my database like during the day. But I can be a bit less brutal. I can say, you know what? Let's just rate limit. I will allow that query to run, but only one time in parallel. If it's run more than one time in parallel, annihilate it. Alternatively, I can say throttle that. So allow it to run 2 times in parallel, but behind the scene, maintain a queue that makes sure that my database is not being hammered. You will wait. You throw idiotic queries on my database, you will wait. I'm not going to interfere with what you do, but you will wait. So these are these are some of the things you can do with Rapido. You can also do caching. So I can actually go ahead and cache that query. So I copied that query text before. And one of the things that we do that nobody else in the world do is cache invalidation or table-based invalidation. Table-based invalidation will give you the ability to deploy caching rules without any business impact. The only impact that you'll have on business is that it's going to run much faster. How come? So typically when developers are using caching, they use TTL. And when they use TTL, by definition, we sacrifice consistency. Using table-based invalidation, you don't sacrifice consistency. So if you have a query that is thrown on your database 5,000 times in parallel, and the exact same select star that is making all the noise in your PagerDuty or whatever, just cache that. Cache the mofo, use a rule. You could cache, that's it, we're done? Yeah? No? Okay. So I can cache the query, I can cache the entire table, okay? So I have very extensive tools here to protect my database from bad stuff to happen, right? On top of that, we have a very strong alerting system. So you can do basic stuff like, you know what, tell me whenever I have more than 60 seconds query on my database, just let me know about it to Matan at Rapido.io. Not every query, but only those, sorry for my French again, those idiots who do select star from any table, right? You're not going to do select star. You're going to do select star. It's going to take more than 60 seconds. I'll know about it. And you know what? Not only that I'll know about it, I will kill your connection and I will know about it. Okay? So I got very strong. I can deploy it on a bunch of my databases. I can deploy it on all of them. So this is, again, a very extensive platform. You could do a lot of crazy things with that. We typically recommend, it sounds like they're having fun there. We typically recommend to be cautious. We help with that. We don't just send you to go and block queries. We do a lot of customer success sessions, but typically our customers are reducing their SLA issue, the P1 issues, to almost zero. Okay. So CPU spike that is killing my database, those days are over. We can actually protect that. And connections that are hogging all my resources, those days are over. We can actually mitigate that and make sure that no idle connections will max out your database connection anymore. So all these tools in your hand, and let's solve the problem. Let's solve this previous problem. So I build that rule. I'm going to enable that rule. So throttle 2. And now I'm going to do, by the way, this is a mass destructive query, right? Like this one. So I'm going to kill it. I'm going to pull the trigger. And now it's gradually, and here's my mic again. Now you will see how it's gradually going to go down, and you will see my graph here being fixed, and it will not cross. Now it is still going down. It takes a few seconds to kill 200 queries in parallel, but in a nutshell, it's going to go, well, during that session, don't worry, it's going to go to 2, and it's not going to spike my database again.